There are 5 parts to this activity. First of all, students will identify some common plants in their local area, becoming familiar with the kind of plants they will see when collecting their data. Next, they go outside and use a quadrat to collect and record a sample of the distribution of plants in a local green space. They then turn this information into a data set and use this data to create a simulation model using Excel. Finally, they critique the model by comparing it to the real world. Students often answer questions about data, but have fewer opportunities to solve problems or represent the world with data. This activity encourages students to use data to build a simulation model, connecting ideas of data, proportion and probability through the random integer function in Excel. By critiquing this model, students are supported to develop an understanding of the limitations of probability models and the importance of the underlying data to their quality. Some important points to consider when you do this activity with the students. The activity can be split into 2 main sections. First, data collection, and then model building. We recommend splitting these across at least 2 lessons. During the data collection, students will need to record the names of species of plant. There are a few ways you can support them in this. First, by using tools such as the Seek app or Google Lens, and there is more information about how to use these at the end of this video. Alternatively, you could consider producing your own information sheet of common plant types found in the area where your students are going to collect their data. When collecting the data, students will be using a quadrat. This is a metal grid that can be placed on the ground so that the plants in each square can be recorded. Science or geography departments in your school may have this equipment available. The data collection sheets and the model are set up for a 10 by 10 quadrat. However, if the quadrats available to you have different dimensions, you will need to adjust these resources before the lesson. Students should be encouraged to invent their own approaches to collecting the data. This could include shading regions of the data collection sheets to represent plants, writing lists of plants in the grid squares, or creating an icon key and notating the grid squares. They will need to collect between 5 and 10 filled out grids and should be encouraged to think about where to place their quadrats in order to get a representative sample. It can take some time to complete the grids, so we recommend getting the students to work in groups to come up with a data recording method and then fill out the data collection sheets individually so that they can pull their data. You may also suggest that they take photos of the quadrats in place so they can refer back to the images of the original data source when back in the classroom. Back in the classroom, students will need to reduce their data to 1 plant per grid square in order to use the model. Then record the number of grid squares for each plant type. For each completed grid, they then transfer this data to a column on the Data tab of the spreadsheet. It's important that every plant type that they identified is given a row in the spreadsheet, and where a plant type is not present on a particular grid, a value of 0 is put in the corresponding cell on the spreadsheet. There is a formula for the mean of samples and proportion for models in the example row of the table. This can be dragged down to populate all the rows in the student's data. Before you begin the modelling activity, we recommend that you familiarise yourself with the spreadsheet and how the simulation works. The students will calculate a crude proportion for the average coverage of each plant and use this to fill out the model table. In this table, each plant type gets assigned 1 row for every 10% of the grids it covered on average. So for example, if ryegrass covered 70% of the grid, it would be written on 7 rows in the model table. Random numbers are then generated in the simulated quadrat, and students use conditional formatting to assign a different colour to each plant type represented by the numbers. So for example, if ryegrass is represented by the numbers 1 to 7, students would assign a single colour to these numbers to represent ryegrass on the simulated quadrat. In the final part, students should spend some time discussing and critiquing the simulation. This is a very important part of the activity and sufficient time should be given to it. The model is deliberately crude with lots of opportunities for students to suggest problems and propose ways to improve it. If students took photos of the quadrats previously, you may wish to encourage them to compare this to the simulated quadrats. First, open the app on an iPhone or Android phone. Click the camera icon at the bottom of the screen and point the camera at the plant or animal you want to identify. the name of the plant or animal will appear at the top of the screen. Taking a photo will bring up additional information. With a photo of the plant or animal you want to identify saved to your computer, open Google and click on the search by image icon. Find your photo and click Open. In the search bar, type or select what is the name of this plant. The name of the plant will appear in the search results, and you can find more information from reputable websites.